Hey guys, guess who just did this whole lesson and forgot to record it? Yeah. Anyway, let's go ahead and do that again, but this time, yep, I'm recording. Okay, let's go ahead and erase all this and start over. Okay, and we're back. Okay, so let's go ahead and get started. Now, we're going to be talking about graphing secant and cosecant in this video. So let's start off with this paragraph right here. When sine is equal to 0, the cosecant is, well, let's think about that, okay? If we have sine of x equals 0, the cosecant of x is the reciprocal of 0. And the reciprocal of 0 is 1 over 0. And 1 over 0 is undefined. You can't have that. You can't ever divide by 0. So cosecant is undefined. And there will be, well, what do we have when we have undefined values on graphs? It will be an asymptote. So we're going to have an asymptote on the graph. Likewise, when cosine is equal to 0, the secant is undefined, and there will be an asymptote on the graph, right? So sine is a reciprocal of cosecant, and then cosine is a reciprocal of secant. So the same thing holds true for cosine and for secant. Now let's go ahead and figure out how to actually graph these, okay? So we're going to go ahead and graph important values of the cosine function. So I don't really, well, we're going to go ahead and graph the cosine function as a whole. All right, let's start there. So we're going to go ahead and just start by plotting points of the cosine function. So cosine function at 0 is 1, at pi over 2 is 0, at this point right here, which is technically pi. You know what? Let's fill those in really quick. Okay. Now we have those. Now that we have those x. Okay. Now that we have those x values, we can go ahead and continue plotting cosine. All right, and now we have cosine. We can actually go ahead and plot, connect dots. All right, now let's go ahead and see what happens when we try to graph secant. Well, we're gonna graph secant based on cosine. So really, we got to think about this again. All right, so whenever cosine is equal to 0, so cosine is equal to 0 at all these points right here, then secant is undefined and there will be an asymptote on the graph. Okay, so secant will be undefined, and so there's going to be an asymptote there. Okay, so asymptote, asymptote, and there goes another asymptote. Okay, and now let's see what happens at the rest of these points. Now, I'm going to tell you right now that at the top of each hill and at the bottom of each valley, both cosine and secant will have the exact same points. And if you want to know why, well, let's think about this. If cosine of, let's say, 0, if cosine of 0 is equal to 1, and I'm looking for its reciprocal, the secant of 0, well, the reciprocal of 1 is just 1 over 1, which is still just equal to 1. And so for that reason, these are going to have the same points, and I can plot it like so. It's actually going to be sort of like a parabola pushing away from that top of that hill. And right here, we can go ahead and push away down here and push away down here. And these are going to be negative for the exact same reason. They're going to be the same value, just negative, because, you know, the reciprocal of it, say, for example, if this was just x and this was -1, then it'd be 1 over -1, which is -1. So again, at the bottom of each valley and the top of each hill, you're actually going to have the exact same point, and they're just going to push off of each other. And then once you have this plotted, you can actually go ahead and erase your green line, which is your cosine, and you have the graph of secant by itself. Now, when we're talking about its domain, we can go ahead and say, well, the domain is going to be from -infinity to infinity, with the exception of these asymptotes right here. And how often do they occur? Well, we can see that they occur at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. In other words, you can say that the domain is a set of x's such that x is a real number, not including, sorry, forgot the real number part, real number, not including pi over 2 plus n number of pi's, any integer number of pi's, any integer times pi, so pi over 2 plus 2 pi plus 3 pi plus 1 pi plus -1 pi. Remember, n is any positive or negative integer. Integer meaning whole number. All right, let's look at the range. Now the range is going to be pretty simple to see, right? We have from -1 it goes down, and from a +1 it goes up, and so there's nothing in here that would be included in the range. So we can go ahead and say, all right, well, it's going to be from -infinity to a -1, and we're going to use a bracket there because it is including -1, and then we're going to use union. And we're going to go ahead and say, well, it starts back up again, right? That union denotes a skip. It shows that it jumps, but it's still connected. It's still one function, so still one range. From a +1 all the way to a positive infinity with a parentheses. Now, there is another way to write that range. You can go ahead and say it's a set of y's such that y is, we could say less than a -1. Sorry, less than or equal to -1, comma, or y is greater than or equal to a +1. So both of these should work. And then the period is actually going to be the same as cosine. So a lot of this is going to be the exact same as its reciprocal trigonometric function. So if the period of cosine is 2 pi, then the period of secant will also be 2 pi. And since we didn't have any transformations here, the period is just going to be 2 pi. So let's look at what happens when we do have some transformations. Okay, so first and foremost, we're going to go ahead and I want you guys to treat this as if it were just cosine by itself. Okay, so we're not going to worry about secant right now, we're going to worry about cosine. And cosine, well, first of all, the amplitude for this would be from 1/2 to -1/2, right, because of that. But then it also shifts up 1, so this is going to go all the way up here to 1.5, and this is going to go all the way up here. So we can actually go ahead and erase this. We don't need it. And we know that our cosine graph is going to be between these two lines that I've drawn here. All right. We know that cosine starts at 1. There are no other transformations, by the way. It's just the amplitude change and then that shift up. So we're going to go at 1, and then at pi over 2, we're going to have the same period. So we're just going to draw cosine like if it were not changed at all. And on the negative side as well. And we can go ahead and plot this like so. So now that we have cosine, we can actually go ahead and, following the same rules, anytime it goes through that middle, we're going to have an asymptote. And then at the top of the hill and at the bottom of the valley, we're going to have the exact same values for both cosine and for secant. And we're just going to draw, they're not exactly parabolas, but they sort of look like that, just pushing away from the cosine function. And then, of course, we can go back and erase our cosine function. Oops. And there we go. Now, let's go ahead and fill out the information that it's asking for here. Reflection, there is none. Amplitude, there is none. This is true. Even though cosine does have amplitude, secant actually doesn't. Secant and cosecant don't have amplitude. That's only sine and cosine. Period is going to be the same as cosine, and it wasn't changed. There was no b. Remember, it would be 2 pi over b, and technically here our b is 1, so it's just going to be 2 pi. Important values is going to be your period, which is 2 pi divided by 4, which is going to be just pi over 2. For my phase shift, I didn't have anything in here inside the parentheses, so there's going to be no phase shift. And for a vertical shift, yes, we did have a shift of up 1. And so this is it. It's really that simple. You go ahead and plot cosine, and then using the graph of cosine, you can actually get the graph of secant. Okay, now let's go ahead and look at cosecant. So cosecant is actually going to be very similar to secant, but instead of using cosine, we're going to be using sine. So your first step is going to be to plot sine. And once you really understand what you're doing, you don't even have to plot the graph, but rather you can just use, like it said, the important values. So these dots are the only thing that I'm going to plot from sine, right? Because cosecant, well, anytime sine is 0 is going to have an asymptote. And then at the top of the hill, we're going to push away. Bottom of the valley, push away. And this is it. This is all we have to do. The domain is going to be very similar. So from negative infinity to positive infinity, except for the asymptotes. But this time the asymptotes occur every single pi times n, any integer value of pi. So we're going to say the domain is a set of x's such that x is a real number, except for when you have n times pi. Okay, so no 1 pi, 2 pi's, negative 1 pi, 0 pi. Those are all integers, so none of those are going to count. The range is going to be basically the exact same thing for secant. It's going to be, from negative infinity to negative 1 with a bracket and a parentheses. Union from, bracket 1 to a positive infinity. And then your period is simply going to be 2 pi. And to graph these, it's going to be the exact same thing as you did over here. You're going to go ahead and graph sine, or just plot the important values, the important points. And then from that, you're going to go ahead and find your asymptotes and find the top of the hill and the bottom of the valley and just push away. If you guys have any questions, please let me know. But these are really very simple as long as you know how to graph sine and cosine.